Question number 4, two Boolean function in minimized form. So this one is doesn't mean it's a min term. In terms of this, doesn't mean it is a min term or max term. Means in minimized form means it is in the simplest form. Okay, if you can see it is in the simplest form. What? Because if you see A, B, C, this is three variable. However, at one of these literal doesn't have B. Like this doesn't they have C. So this one is in minimized form, but it is not a POS or SOP, because POS and SOP, like we must have all the variables present. Okay, so this one is minimized. Okay, map the function into the KMap, write suitable expression and implement them using 37410 chips only. So means using 3 complement of an input is not available and require a not function. Okay, before I show you the final answer, because it will shorten our time, but I just want to make you understand for some of you that maybe you don't understand. Okay, then I show you the final question and you retry again at home. Okay. Because if we can discuss this, but we will start discuss at this question only. Okay? Is it okay? Okay. I will show you something to make you understand first. But other than that, you will try yourself at home, because otherwise you don't have time. Okay? You see here, this one is minimized. Okay? What happened? Oh, battery finish. Okay, my battery finish. Never mind. I use my fingerprint. Is it okay? Fingerprint. Oh, fingerprint also cannot. Okay, never mind. Wait. This battery, I have to order online, because it's a special battery. It's small one. Doesn't you cannot buy it DIY whatever. Okay, so I put here. Okay, so I'm using finger now. Okay. Okay, so first it said this is minimized form, means you need to expand it. Okay, you need to expand. For example, A. What's this one? Sorry, it's difficult to teach like this online, because I have to see your chat, I have to see your response, I have to see the question. Map. Okay, then you make the because you have this information now, you can make a truth table. Okay, you can make a truth table. Okay, containing three variable and the answer that having the answer of 1. Because this one is when we expand, it become SOP now. Sum of products. Okay, then you make your K-map. Okay, because this one is 3, so you have a 3 variable K-map lah. Okay. And then write suitable expression and implement them using 37410 chip only. 7410 chip has 3 input. Oh, okay. Okay. Don't save. Okay. Then after that, you need to connect to. Okay, this one they didn't mention. They didn't mention what is the assignment of the chip. But they say there is 3 input of 3 units of 3 input NAND gates. Means you have A, B, C. Okay, this one is 3 input that we already have, and 3 input of NAND gate means you have a NAND gate. You have 3 inputs. Then you have to connect them according to your expression, the one that you obtain in KMA. And then they mentioned here, okay, complement input is not available, means it is not excluding the inside the question, means this one you have to provide yourself. Somewhere here you may require not function. Okay. Somewhere here you require not function if you require them. Okay. So this is actually the how to solve it. Okay. Then this one is actually all inside this. This is considered as 74 times 7410 chip. Okay. And this one is the output if you see from the outside, okay, outside of the chips, which is we have A, B, C. Okay, so we go to the final answer because I want to shorten our time. You guys try at home. We don't even have time to see the Padlet. Sorry. Next time, it's okay. It's better you know the final answer. And if you want to, you will try at home. Okay. Wait. So the final answer for question number 4, I just show the final answer. Okay. I give you 1 minute to take down, or maybe don't need because it's recorded. Okay. Because it is recorded. Okay. So this is the answer. Okay. How can this? Okay. So try this at home. You remember NAND gate is actually also can perform as NOT gate. Okay. You just need to double or triple the inputs. Depend. Okay. Because this one still sorry, this one still perform as NOT gate, this one also as a NOT gate, and so on. Okay. Okay, so this is the answer. What else you want to know? I don't think okay, you guys can do now, but you guys can check now your answer. I give 1 minute or 2 minutes because recording will take time. Means I will not share today, maybe tomorrow, because you know sometimes it take time to generate, and sometimes we go to other works first. Okay, so you can check your work. I give 2 minutes, then we go to the next one. Okay, while you guys doing the tracking your answer, may I know the next question? This is the benefit those that come to the class. You can know the answer and I can do some explaining, but we cannot cover all. Okay, we cannot cover all. Then we go to the next one. Okay, question 14. Okay, I will go to that after 1 minute. Because you guys need to check first your answer. So what is question 14? A 6-segment display is used to show the direction of north, south, east, west. A decoder is connected to the display. Design the decoder using Ni baru suruh kau macam mana. Okay, now we go to the next question. Is the question number 14. Okay, question number 14. Decoder. Okay. So make sure you understand decoder well, everyone. Okay. Because decoder and encoder are about the same, but hopefully you understand how decoder operate. Okay. So a 6-segment display is used to show the direction of north, south, east, and west. A decoder is connected to the display. Okay, so this is a decoder. So this is your display. Okay. What else? Design the decoder using 17486 integrated circuit chip. Okay. Sometimes depend on the question, depends on the some people that making questions. Sometimes we provide the data sheet, means you need to read from data sheet. I think I have not go through to you with you yet. Example of final exam, I think example of final exam where we require student, we provide the data sheet. You need to extract information from that. I don't think we have gone through that yet because we are busy covering the syllabus. Um, because the data sheet is inside the module. Okay, but since no one asked me yet, okay, means no one even bother to see it. Okay, but it's inside inside the module. Okay. Let's see when we will have time to cover the data sheet. Okay, but the data sheet actually some information. For example, T delay. For example lah, okay, never mind, we go later lah. Okay, we go later on the data sheet. Maybe you will, maybe, not sure. Even if it's come into question, maybe it's final exam lah, not test. Okay. Okay, 86 chip has 4 unit. 4 unit of 2 input exclusive OR gate. So you have here is exclusive OR. So you have 2 inputs. Okay, and then you have 4 of them. Means you have XOR gate 1, XOR gate 2, XOR gate 3, XOR gate 4. Okay. Design the decoder using 17486. Okay. 6 segment display is used to show the direction. A decoder is connected to display. Design the decoder using a 74 chip. Okay. So this one is the this is what? S0 and S1 is what? Okay, it is a selector. So means you have a lot of this. Okay, you have a lot of this. Then you have a selector. Okay, then you have a selector. Selector S0 and S1. So how are you going to connect this so that it is going to show the direction? You see here? Okay. So you need to make a table. This is decoder. This is decoder. Then you have A until what here? Until F. Okay. And you see here the output here is 6. So it's not, you see the output here is 6. Okay. It's not the number that we, how to say, it's not a number that, for example, 2 times 2 is 4. 2 times 3 is 8. This one is not complete. Okay. So that's why I design, maybe some of the things you don't need. Okay. Don't care. Okay. Okay. So then you have okay. So wait number 14 Okay, just what I expected lah. The answer. Okay. So you have S0, then you have S1. Okay. Then you have all the possible combination that showing the north, south, and north, south, west, and so on lah. Okay, and if you see this one is doesn't show whether this is wait I'm trying to wait. What page is decoder? Okay, decoder. Okay. So in decoder, wait. I'm trying to referring to the figure that have this decoder page 109. Enable. Okay. So it doesn't have the enable. Okay. It doesn't show the enable data. Okay. Means it doesn't show first. It doesn't show the enable, and if it show the enable and it doesn't show like clearly what is, means that it is a high enable lah. If it's with bubble means low enable. Okay. Doesn't show inside here for the chip. Okay. Of course. Okay. So you have A until so on. Okay. Then you put your possible combination. For example, north is what? What is turning on the north? Is A, B, and E. So you have A, B, C, D, E, and F. Okay. So to turning on the on function, you have 1, 1, 0, 0, 1, 0. Okay. So this is the things. Okay. So and so on. Okay. So I give you the answer, the final answer. You try at home. But Joey, did you try it at home? We have no time to cover this because I have other class. That's why. Not class lab. I think I show you guys right. My schedule today is quite packed. Otherwise, I would have a more extended session with you guys. Try to understand what you did and what you did wrong. Okay. So this is the answer. Okay. I give 2 minutes. Try to check. And of course, this one is recorded. If you want to check now, it's okay because I give you time. If you wait for the recording, yes, you can wait, but it's after. Maybe not today. Maybe only share tomorrow. Because I already informed there is delay. I'm waiting for the system to generate the recording and then I upload to YouTube and then I share to you guys. But today is quite packed, so means I'm not going to do it today. I mean, I'm not going to do during the day lah. Okay. So this is the answer. Joey, do you get this answer? Or you don't get it? So there is 4. No, doctor. Okay, it's okay. So you have the, see, this is because they provide 4. Okay, now you have the answer. Try at home. Okay, you did. Okay, of course I didn't know who have tried, who have not. But like I say, if you try, you get it. Like, you don't sit down and suddenly getting A fall from the sky, right? You have to work for that. Okay. And after that, what question? What question? The rest easy, yeah? How about question 16? This is multiplexer. I think you guys didn't try because I think you guys didn't try. I think you guys didn't try and because I was a student also. I was a student, so sometimes we have other subject. We have other subject, and then maybe other subject have assignment or quiz. Maybe you ended up didn't do all lah. But if you didn't do, then okay. So we go to the next question. I think we try to see the multiplexer here. Okay, the multiplexer. So multiplexer also is quite important chip lah. Okay. Okay, a Boolean function is implemented using a 74138. I think in the final exam last time we are giving data sheet for, I need to see. I don't remember past year. Some more I didn't teach this subject last semester. I teach the previous 2 semesters. Okay, so if I'm not mistaken, we are giving data sheet. Maybe this one for the final. Forget. Okay, I need to see. Okay, a Boolean function is implemented using 74138 decoder. Okay, a Boolean function is implemented using 74138 decoder. So you have to know what is 74138 decoder? What is the operation inside? Okay, if you go to the module, okay, what page you have this decoder? Maybe because I'm having the old book, whatever I have may be different than yours. 74138. Did they put this inside? They should put it. Right? 74138. Hmm? Why they don't put? They either they put or because I just see the pages in random, a decoder. Wait, they put or they didn't put? Okay, I think not sure. Okay, this one if this okay because this is a exercise, so you can Google. But I don't if it's in the test, I don't think they will give like this only because otherwise you didn't know it. Okay. Okay. Wait. Go to 74, 74. Wait. What is this? 74, 74, 138. Decoder. Okay. Wait. Don't know why it's slow. Okay. So this one is 74 times 138 lah decoder. Oh, I have lab after this. Okay. Uh, okay, you can see like this is the 74 138 decoder. Okay. So you can see you have your input ABC. Then you have your output 0 until 6 here. Okay. 0, 1, 2, 3, 4, 5, 6, and you have your VCC and ground and so on. So this one is 74 LS138. Okay. I don't know about the internet. It seems slow. You see, even to generate this. Okay. So this is beyond my control. I'm not controlling the internet. Okay. So I don't know why it's delay like this. Okay. This is basically the decoder. So decoder is less to many or many to less? Decoder. Decoder is less to many or many to less? Important, less to many, okay. So encode less to many, and then encoder is actually many to less. Okay. Okay. Wait. Okay. So and then how about multiplexer? Multiplexer is many to less or less to many? Multiplexer. Actually, my question is already have answer inside the question. I mean, when I ask, you already have the answer. Multiplexer, is it many to less or less to many? Okay, in this figure, tell me left is what, right is what? Can you guys tell me? Left A is what chip, B is what chip? Not the specific number, but the chip. A is what, B is what? Can you tell me? A is what, B is what? Problem, if you guys don't know how to differentiate. A is what, B is what? Ah, the question is there. The question is there. And the answer is also there. A is what, B is what? I'm not scaring you guys, because by now you should already know how to differentiate the chip. And even you don't, okay, for this question, for this particular question, even though you don't know, the answer is already there. The answer is already there. Okay, so Joey is correct. Nurul Ana is correct. And Nadira is correct. So, like what I told you, the answer is there. They give you the answer already. Okay, means 74 want to add decoder is this. Okay, and then they want to implement the same function using 4 to 1 multiplexer, means this one is your multiplexer. Given also. So even if you didn't know, it is here. So they want you to design uh, that multiplexer so that it perform the same function as what you are currently having with your decoder. So they want you to perform the function so that this multiplexer apply, implement the same function. Okay. So you have your ABC. Okay, ABC. Then you have this AND gate. Okay. Okay. Mm, S0. Sorry, S2, S1, S0. Okay. And then you have the outputs. Okay. Output 0 until output 7. Okay. Why we have output? Because this one is 2 to the power of 3. Okay. Then you have all possible combinations. Okay. But take note. Is this one is uh, inverted. Means what is the active output for here? Is it 0 or 1? What is the active output here? 0 or 1? The active. What is the active here, output here? Let's say it is high, but what is the output here? 0 or 1? Here. 0 or 1? It is 0, yes, it is 0. Okay. So you need to make a connection here. 0, 0, 0 until 1, 1, 1. And consider this. Okay. Consider this function. If they give this as exercise, must be inside this one. I am looking where is the chip inside the module. Did they give it to you? G to A, G to B. I think in the test or final they should give. This one luckily exercise. You can Google. Okay, you can Google. Okay, you can Google what does it mean by G. Okay, so this one is an enabler. This one is enable. So if you have G1 equals to 1 means it's enable the decoder function. Okay, for G to A, G to B, you can see 0, 0 means it is activated. Okay, so you perform the same function here, but however you see it's only taking up partial output. This one is I call it partial output lah, means not the finalized output. So you can see it's only taken at 0, at 6 and at 7. Okay, then do the same function for S0 and S1. So means you need to do some K-map or whatsoever. Okay, to table you complete this and you do the K-map and try to implement the same thing using your multiplexer lah. Okay, so let's give you the answer for that. Okay, the answer. Wait. It's not that I don't want you to give you the answer. I want you to try at home, but not sure you guys do it or not. seeing the answer and trying it and see the answer later is different thing. Okay, so this is the answer. When not sure you guys do it or not. Okay, so this is the answer. I give you 2 minutes. You remember the recording is later, maybe tonight or tomorrow. So if you have the time, just take it down, the answer. Even if you don't do, my gut feeling say you guys didn't do lah. But it's okay. Cause time, you have other course and I'm sharing, not I'm sharing quite late because I have the option not to share. Because this one I get from the other lecturer. Then I just ask, do you guys want it? Something like that. Means I also have it late. Okay. Regarding the quiz, because I am outstation later, maybe we don't have the quiz on the weekend. Maybe the quiz is on the, maybe I will inform again. Maybe the quiz will be on the 20 lah. Because 17, 19, I will be not here. Okay. So take this answer and try at home. Is this exercise showing, sorry, showing the adding function? Oh, here. Number 18. Okay, I just give you the answer for 18 later on. Uh, I hope you guys can know how to, I hope you guys, for example, question number 18, we have arithmetic logic. I hope you guys do the exercise and I hope you guys know how to do addition, how to do subtraction. Okay, and the module exercise is actually already inside. Okay. Okay, question number 18 is about addition and subtraction. Okay, so question number 18. Arithmetic logic circuit. Arithmetic means we're going to perform zero, or we're going to perform addition, subtraction, division or multiplication. Okay, in in circuit we doesn't have for example 1 minus 1, no, but we have, okay, where's my pen? Oh, here. Okay, so don't save. So you have in a, in circuits we do arithmetic circuit, we have, if you want to perform 1 minus 1, okay, we don't have that, but we have 1 plus minus 1, so it's the same thing, right? Can you guys tell me how we're going to achieve this minus 1 in our arithmetic circuits? What should be doing? Now I'm testing your understanding, because this one is a topic that may be covered in the test, because it is shown it's covered from topic what, I forget, topic 6 or until topic 9. So means arithmetic is still inside the possible topic that will be covered. So if we want to do this minus 1, I mean we cannot do directly in circuit 1 minus 1, but we can do 1 plus minus 1, means still 1 plus negative 1 means still the same, 0. But what should we be doing with this minus 1 in the arithmetic logic circuit? What is it? How to represent negative 1? Can you guys tell me? If you huh? Semi-negative. The rest? The rest 5 of you is only 5, huh? Okay. The rest of you? Triple adder. I'm seeing your module right now. Others? I hope you guys do the exercise, do the module exercise also, because we have the question. I mean, we have exercise in the module, and we have answer now. Your left is, many. If you want to learn a lot of exercise, you already there. Okay, but I cannot force you. Please do. Please do. Okay. Operator. I think I asked last time to do exercise number. Okay, chapter 9. Chapter 9. Only Joey. How about the rest? The question using half adder. Okay, try to do question number 9.1, 9.3, 9.1, 9.3, and 9.5. This one is adder. The answer is at the back. You have the answer at the back. 9.1, 9.3. This is your try. You try it yourself. I won't be like, okay, must submit now. Okay. 9.1, 9.3, 9.5. Okay. Okay, they didn't put. Okay, let me check this. My module is arithmetic. Okay. Not module, my question. Okay, you see how you perform it is with, you see this? With inverted. Okay, it is performing the subtraction. Okay, with inverted. So it's already there. So I'm not sure you guys try or not. I did ask you guys to try, right? We already have example. You need to try and then you get the answers. But if you don't try, how? I'm not sure. Okay, so this is a subtractor. Okay, for example, 0. For example, this is 4. This is negative 6. Okay, but the question is asking n bit adder f equals to a plus b can be converted to subtractor g equals to a minus b. Okay, we take the two complements of b, so invert b and plus 1. This is second complement. Second complement. First, we take this first complement first, then we add plus 1. This is one of the steps to get the two's complement. After that, we perform g plus minus b. Means this one is already been turned into negative number. Okay, means complement. Given a is equals to 0, 1, 1 and b equals to 0, 1, 1, 0, perform a minus b. Okay, so this one is just addition. Okay, just addition. You see 0, 1, 1, 0, but this one is already means negative 6. Okay. 1, 0, 1, 0. Okay. So this one is subtractor. Okay. So I give you the answer. Please try. Please try at home. Okay. Where is the answer for this? I'm not sure even you try the slide. I have shared the slide, right? Because this one is very... Have I shared the slide or not? I think I shared already. Have I shared the slide or not to you guys? It's a dumb question, but I just want to why I'm asking this because I'm not sure you guys download it or not, the exercise. Okay. So for question 18, I give you the final answer. Okay. Try this at home. Okay, here. Okay. I give around 3 minutes. Try take the answer because don't depend on recording. Okay, this is answer for 18. 0, 0. So the question is, arithmetic logic is an important part of microprocessor. It performs arithmetic and logical function. Okay, the diagram show 1-bit slice of an ALU. ALU consisting of several logic gates, multiplexer and a full adder. By inspecting the circuit, identify the function of the ALU by filling the given table. Okay. 1-bit slice of an ALU consisting of several logic gate, multiplexer and a full adder. By inspecting the circuit, identify the function of loop by filling the given table. Oh, this one is not that. This one they already give the logic gate and you need to fill in. But can let's say if we ask you the other way around. Let's say we give you this operation, for example, 40 minus 40 minus 50, for example lah, 40 minus 50. Can you actually show it in the circuit? How it can be carried out? This question, the one that we question 18 is instead of it's reverse. It's give you the circuit and you need to get the expression. But we can give you the operation and we want you to come out with the circuit. Okay. So take down this answer. Okay, another 1 minute. Okay, what else? What else is worth to be discussed in this exercise? But I give you time to take down. Try at home. Those that benefit that attend the class, you get the answer now. Final answer now. And those that didn't come, they may be a bit late because it's recording. Okay. So now we go to the next one. This one. Okay. A Boolean function. Okay. This one and this number one is you keep being seeing this POS SOP. Make sure you understand POS SOP because sometimes it's been repeated in many chapters SOP POS but you need to understand solve question more about SOP and POS okay. So means at least you should do this exercise maybe to freshen your memories like this one is POS POS. So it is it given you in terms of SOP. It given you in terms of SOP and don't care. Now it instead of asking you to because it's given you the SOP, so you can get the complement which is POS. So you see here okay, you see here is ABCD. ABCD. Then you have 0, 2, 3, 8, 10, 12 and don't care. So can you tell me what is the insight of the POS here? Can you tell me if this is SOP, what is the POS? Inside the bracket. You don't have to give me the symbol. Inside the bracket is what? If this is SOP, how about the POS? Actually, when see this already know the answer, but I don't know why you didn't respond, you guys. If this is SOP, of course this is SOP, but what is the POS? If we want the POS, what should be in bracket? You guys know or not? If you only Hibat, the rest what? What are you doing? Okay, so you have ABCD means you have 0 until 15 combination. Okay. And since that this is donkey 4, 11, 14 and 0, 2, 3 means it is other than that. Okay. Other than that. Okay. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 8, 9, 10, 11. I'm using mouse, no? Oi. 13. My pen already lost. I mean, already out of battery. So, means that it is other than this. 0, 2, 3, 8, 10, 12. And then, don't care 4, 11, 14. Means, your POS is what? This one. Okay, good, good. Means 1, 5, 6, 7, 9, 13, 15. Okay. Hopefully you understand SOP POS. Okay. So I give you the answer. Please try. Okay. So for question number, okay, I give you question. I give you wait. Okay, I give you the answer for number 1 first. Okay, I give you the answer for number 1. You try at home. No, I just give question number 2 lah. 1, 2. Wait. Okay, try this at home. I give you 2 minutes to take it down. This one is 1, 2. Okay. Allahu Akbar. You know, I'm sleepy. I'm playing the music. Because while I'm waiting for you to take down, I didn't do anything because the screen is limited. Okay. Okay, another 20 seconds. Okay, I will give you the final answer for number 3. Final answer for number 3. Also, I will give you around 2 minutes because we will finish at 10:15. Okay. So now I give you the answer for question uh, number 3. Okay. So I give you 2 minutes. we can discuss this. I can discuss each of the question, but we don't have time. Okay, it's not that I don't want to discuss. I hope you guys understand. Huh? We don't have time. Can you imagine one question maybe take me 30 minutes or 15 minutes? Then we end up not covering it. Okay. So I give you another this one. Okay. I give you 2 minutes. Please take down the answer. Because if you wait for the recording slow lah. What else that is a bit difficult? 4 already, just now 4 already. What else that wait, wait. Oh, okay. Uh okay. Question number 7 is good. Question number 7 is good. Wait, what is the answer? Okay. Okay. So question number 7, implement the system in non-null configuration. Okay. Please do question number 7 as well. Okay, it's interesting. Question number 7. Okay. So I'm sharing the question. Is it okay now? Can I move to question number 7? Because I already exceed my time. Can I go to question number 7? Okay, so I go to question number 7. So I just give you the final answer. Okay, sorry because you don't have time. I can explain, but then you end up not finish. Okay. So this is question number 7. So means you need to work whatever you are doing. And this is the final answer. Means this is 7-2. So make sure you get this answer. Okay. Please do question number 7. Okay. I think this is interesting and also important question. It's a design question. Good. Okay, I get 2 minutes as well. So of course, when we do the designs, we have to do the K-map, truth table, whatsoever, blah blah blah, until we get the circuit at the end. Okay. So to take down the answer. At the very least, you do the truth table and you get, for example, if you want to gather the answer for output for 1, so you will use SOP. If you want to get the output for 0, you're going to use POS. But you need to know what is the requirement of the question. Question now require you to use only no. Oh, you see, that's why I don't like this WebEx. I have to wait until this one go up, then I can touch the pen. What can I do now? I don't want to use WebEx actually, but it's one of the things that actually recordable and unlimited. I mean, for student, if student account is 1 hour, but lecture we can record more than 1 hour lah. But Google Meet not able to record anymore. That's why I'm using WebEx, even though I don't like WebEx because it's heavy. Huh? The circuit may be different. The circuit may be different. Okay, but you need to only use NOR. Okay. Okay. Circuit can be different because I cannot answer now because I didn't try the question. I already have the answer. But the circuit can be different, but make sure it's still performing the one that has been mentioned in question number 7, the condition. They mentioned here 4 shareholder A, B, C, D hold 40%, 30%, 20%, 10% shares in the company respectively. Okay, I need to go to other class. Okay, never mind. Their voting powers are reflective of the number of shares they hold. A high input indicates a vote for particular decision. Any executive decision will be implemented if the shareholder okay. Here, you see, because we have holding power, okay, means A is actually more greater than B and B greater than C, C greater than D, because this is based on the 40, based on the shares lah, okay. So here, any executive decision will be implemented if the shareholder vote is 60%. A high output if F indicate votes of 60%. So means, for example, if this one and this one vote for it, then we go for this one because it is already more than 60%. And then let's say this one 40%, 20% means it's already, you see, more or equal than 60%. So you can see this one, okay? You here, if a high output, if F indicate vote of 60%. So you have so you have A, B, C, D. Okay, you have this is 40%, this is 30%, if I'm not mistaken, this is 20%, this is 10%. So let's say if you have 100, so this one is already 70%, so the output is already high. And then the next is for example 1100. Of course you do this in order, I don't have space. So for 40% plus 20% is already 60%, means higher, so this is 1. Okay, and then let's say if you go for 36, this one means 011, it is high because it is 60% or more. It's already equal, so it's 1, and so on. Okay, so with that we finished the session. So I need to go to lab. Actually I'm already late. The lab start at 10. Okay, so okay, all the best. Thank you very much. Assalamualaikum. All the best.